Yeah, so the thing I did is that I did not first learn how to use the live functions in the YouTube. So that's why I'm facing quite a hassle now. I don't know how all the things are working, how everything is holding together. So what I'm trying to do is I'm trying to see how things are working. And today, my and today seems like my studies are really being hampered because of this live, which is really counterintuitive because I was supposed to be more dedicated to studies thanks to this live. Hello, I don't even know if the mic is working. What a disaster. Anyway, so no one is here, so it doesn't matter actually. And day by day, I will improve my quality, my dedication, my studies, and already I feel really sleepy. Hmm? I just realized now that this whole time my mic was muted, which really sucks. My mother made this mango mango juice, fresh mango juice from fresh mango, homemade. Anyway, so let's start with the studying part. Chasm, chasm means a greater cleft. What does cleft mean? Cleft. Chasm means cleft, not border, not hatred, not top. The word emancipation is emancipation. It should be liberation. Liberation. The text is a report prepared by a news agency and English language newspaper series and interested to publish it in a shortened form. Write a summary of the report. Miller was among the first to advocate armed resistance to apartheid, going underground in 1961 to form the ANC armed wing. He left South Africa. He left, he left South Africa and traveled the continent in Europe, studying guerrilla warfare and building support for the ANC. Branded a terrorist by his enemies, Mandela was sentenced to life imprisonment in 1964 as isolated from millions of his countrymen as they suffered operation violence and forced settlement under the apartheid regime of racial segregation. He was imprisoned on Robben Island, a penal colony of Cape Town, where he spent before moving to Neighborhood prisons. In his later years, he met President Peter Bender was treated in a for and later required an operation to repair the light of his eyes as his treatment was cancer and his tooth, however, be was strong. Bender was treated in for 1980s. Next to the was if cancer wins, I will still better win. Remain will still be the better winner. Victoria Borisima further in September of the year. When I go the next world, first thing I is look for an answer of his renewal. For we choose look for an answer of his renewal. Proud to tuberculosis. Nelson Mandela.
নাম কি?
Okay.
যে
I've completed my first subject of the day. Let's English first. Seems to be off. Seems like someone joined the stream. Welcome to the stream, bro. Do let me know who you are. What's your name? The problem with today's stream is that I don't even know if my mic and webcam, all of these are working or not. Do let me know who you are if you're still watching. I'm actually doing some work in my website. I'll be right back. Today the studying is not working. The study is not studying. I only finished one of my subjects today. I was supposed to finish all eight of them by 6. Now I have only 30 minutes left in my hand and I've done only one. And also that was the easiest one. The hard ones are still left to be done. Most probably I guess it is one of my friends because who else would to join at such an early time, early stage of my channel. So welcome dear friend. কি করেন ভাই? I was supposed to study. That's literally the name, but I'm doing something completely other than that. This stream is not something that serious right now yet because it's still the first of the year. But from tomorrow, I will take it seriously because today I seem to have some work. The idea was to that the idea behind the stream was that I would uh, open the stream and like study an hours, but reality is quite different. I can see that. Actually, I can talk right now. I'm doing one thing. It's hard to explain what I'm doing, but I'm doing something. So let me cook right now. Last time. Yeah, so I'm done with the work that I was doing. So now let's get into studying. I'm realizing that sitting doing a live stream of your studying is really a bad idea. It's not that effective. It's not that effective. You, I'm ending up wasting more time than if I were to study alone. But if I become habituated with this, I hope that soon, maybe within a week, I will start studying properly in front of the camera. I don't care that there's no one in the stream except me, because the streams are more like a archive of my life, like the proof that I in during my HSC I studied 6 hours, so like all day. So that's what I'm trying to achieve. It's like a video archive of my life. Let's see how far I can go with this. I will take a short washroom break. Mm-mm. I will go myself. I will go make myself a coffee. As I'm approaching like nighttime, I'm starting to feel sleepy. So that's why I'll get myself a cup of coffee to freshen myself. So we are done with English first. Now we will like go with bio first because it is also an easier subject compared to all other things that we have in our list. Bio second part. No, not second part. First part. Also, only one day I did not study, and that's why my studies are now like stacked up a lot. Only yesterday I skipped. I did not study. That's why today. The and the interesting thing is, uh, it is just the starting of the year. Like college is not that easy. Like we're, anyway, so we will start with the biology. Biology is significant of cellular. I need to get a new haircut because my hair is like that of a monkey. Mitosis cell division. Mitosis is a mode of division in which nucleus longus construction and ribonibus are gained to daughter cells. This is followed by centripetal construction of cytoplasm. In which cells elements construct in the middle and nucleus are gained to daughter cells. The following is a centripetal. This is followed by centripetal construction of cytoplasm to form two new daughter cells. Remark in 1950 we discovered a mitosis in early cystic embryo, but that term was known by Fleming in 1882, that is, the nuclear envelope is found throughout the division intact nuclear envelope. Chromatin does contains integrated chromosomes, no spindles, chromatin distribution occurs unequally. Cytokinesis may or may not follow karyokinesis. Where mitosis occurs in yeast cells, amoeba, meganucleus, and paramecium. Nuclei of internodal cell of germ, endosperm, endosperm cells of seeds, cartilage cells, and disease cells. Significance of mitosis. Mitosis is a rare event, but sometimes it is very unnecessary and has been described as a secondary process of solution in larger life forms. Mitosis or equational cell division, body of multicellular organism comprises of two types of cell, viz. What the hell is viz? Here I got myself my evening cup of coffee. Also, it is time for Maghrib prayer, so I will need to pray the Maghrib prayer soon. Uh, oh, seems like there's one guy watching actually. Uh, Most probably, I'm guessing it is Saba. And the funny thing is, from the start of the stream, I've been saying that most probably it is my friends, but none of them are actually my friends that were supposed to be joining. So I can tell who you are. Do mention in the comments who you are. if you are even interested. The cup is too hot. Body of medicinal organs comprise of two types of cell, somatic cells and germ cells. Somatic cells multiply through mitotic cell division. Mitotic division in multicellular organisms forming different organs and systems. Germ cells take part in sexual reproduction of organisms. Division of somatic cells happen in two phases. In first phase, division of the nucleus occurs, known as kerogenesis. After that, in the second phase, the division of the organism of the organism is into daughter cells. This is called cytokinesis. Kerogenesis, cytokinesis. Kerogenesis does not depend on cytokinesis; it divides genetic material equally. On the other hand, cytokinesis depends on kerogenesis. It cannot occur without kerogenesis. All multicellular organisms develop a single cell zygote through the process of mitosis. In mitotic cell division, the chromosomes of the mother cell are duplicated and distributed equally to the two daughter cells. Hence, this cell division is called equational cell division. Um, Strasburger and Slender in 1879 discovered mitotic cell division. German physicist and cell biologist Walter Fleming in 1882 coined the term mitosis. Cockrum and Macaulay in 1960 explained the chemical nature of mitosis cell division. Where does mitosis occur? Mitotic cell division held in almost all embryonic cells of a plant or Animal and the reaches full size material subdivision in all the visual somatic cells of multicellular organism, the visual somatic cells, embryonic cells, the development and growth of reproductive organs of occurs by the development and growth of reproductive organs. In plant muscle occurs in the meristematic tissue, apical meristems of roots and stems, vascular cambium, and the core cambium. Process of mitosis subdivision can take place in haploid as well as diploid cells. In the cell division, each chromosome divides longitudinally to form two chromatids. Both the daughter cells form through mitosis receive similar characteristics and number of chromosomes as that of the mother cell. The original structure of the chromosomes remains unchanged in both the daughter nuclei quantitatively. In mother cell division, both nucleus and cytoplasm divides once. The daughter cells in mother cell division increase into similar shape like it mother cell cycle and also shown through the pre-existing cells of the body through the process of cell division. Actually, continuity of life depends on the cell division. After creation of a new cell, it grows, synthesizes different materials, and then diversity in organism. The total process of cell creation, growth, and division are collectively called the total process of cell creation, growth, and division are collectively called cell cycle by Howard Galley. Strasburger and Schleicher. The cell cycle is an ordered series of events involving cell growth and cell division that produces its new daughter cells. The cell cycle starts immediately after one cell division and ends with the completion of its next division. Howard and Polk divided the cell cycle into four phases, that is G1S, G2, and M phase. Among these phases, the G1S and G2 are collectively called the interphase. M phase is called the mitotic phase. Mitosis phase, nuclear division occurs in mitosis phase. Interphase is the resting phase between successive mitotic divisions of a cell or between the first and second division of meiosis. The interface comprises of the 90 to 95% division of the cycle, and the mitosis phase has only 5 to 10%. The different phases of cell division are described below. Interphase is the phase of the cell cycle in which a typical cell spends most of its time. During this phase, the cell copies its DNA in preparation for mitosis. Interphase is a metabolic phase of the cell in which the cell obtains nutrients and metabolizes them, grows, reads its DNA, and conducts other normal cell functions. The majority of eukaryotic cells spend most of their time in interphase. There are three stages of cellular interphase. G1 phase, it starts immediately after the previous division. Therefore, G1 is called gap 1 phase. Okay, gap 1 or first growth phase. Synthesis of the functional proteins and RNA take place. The cell grows in volume. It covers the 30 to 40% duration of the cell cycle. It's time for Maghrib prayer, so I will be going out for Maghrib prayer. Let me put on the prayer break screen. Maghrib. Okay, transition. See you guys soon. Assalamu alaikum guys. So I'm back. I'm done with the Maghrib prayer, so I'll be continuing the rest of the studies now. As expected, I don't have a I don't have any viewers, but that's fine. So if you guys like there is no guys. So I'm working on a project on a website project that I'm working on. So the thing is, there's some problem in that website. There is a moderator. I have a uncle was a moderator. So he's just telling me that there's some problem in the website. So I will be fixing that now. So like that's the problem of for me that um, others in my age in my class they don't have like any what the hell they don't have like this extra thing that they need to do. But I will I will be doing many things at a time. That's why I cannot focus especially on the studying part. There is an error, so I guess I will need to be fixing that. Well, finding out the bugs. uh Especially when like feeling asleep. Damn. Damn. And that's the thing. Seem like I solved that problem. However, I will just record the video in my laptop screen because it's not that mission critical. I will just use what you call the laptop screen. Like that's the thing about life. Like I plan to do a lot of things in today. Today, the day before today, like yesterday, the day before yesterday. But life and reality is quite different from imagination. Like in the last 6 months, in the last 6 months, I was totally jammed. I was totally free. No studies, no nothing, no responsibilities, no like going to school. Like everything that I was using as an excuse that was holding me back. But what I saw, what I found out is that even though I was not going to school, I was not using my time as productive. I was supposed to be doing a lot of things in the break. I was supposed to do like an awful lot of things. But anyways, like life is not a bed of roses. I will try. Okay, so I'm like, it was a really short fix. I was just showing how to clear out the cache for my website because there was some cache problem. I guess he was facing some cache problem. So that's exactly what I did. I just showed him how to clear the cache for our website from his browser. Like, if you guys don't get it, it's nothing that important. Cache memory is just temporary, like short-term memory for the computer and the website. Like I was supposed to be static, man, but look at what I'm doing here now. Reality is something like really different from your expectations. I can see that some people are joining, leaving, joining, and leaving. It's most probably because they're watching my um, what do you call the story, Instagram story, and they're clicking onto the link, joining the live, and then like just skipping away. And also, why things don't work out for me? Why people won't be much interested on my study with me videos is that because I'm not that handsome. That's one thing. What I noticed is that the other people that make the study with me videos, they're like handsome, they're white, but I'm a black. I have to deal with it. Also, my laptop is starting to work really slow. Maybe because my network is weak now. The stream quality, even in my computer, is showing it's very lagging. I don't know what to do actually. Oh, I found the problem. The problem was that I was like recording and using that same software as a No, that's not the problem. The Yeah, now it's better, I guess. Let me check. The latency is too much. That like I'm speaking at one moment, and after like 5 seconds, the live is speaking. The my net is very slow right now. I don't know why. Because is it because of the many softwares open in my laptop, or is it because my net is slow? I don't know. I guess we would never know. Let's check out my Instagram is if there is something important that I would like to know. And also one thing I'm seeing is that my laptop is starting to heat up. Uh, I had one stand, one fan for laptop, but I took it to my father's office and forgot to bring it home. Fire in a hotel. Retro. In the long run, not the long term, in the long run, you have to make it alone. That's what I'm exactly watching right now. That although many of my friends told me that they would be joining the stream and studying with me, but actually they did not.
Oh yeah, Mia.
I was supposed to be entering Instagram for checking my messages, but what I'm actually doing is that I'm scrolling through the reels and stories. That's what exactly happens. Also, like recently, I changed my like life motivation a lot. My outlook of life. You know what? It's really contradictory. It's really debatable. So I won't be saying that. We will say it later. It starts in after the interface. Interface is the phase of the cell in which typical cells spend most of the metabolic phase. G1 phase and starting metabolic to the previous division. Therefore, G1 is called gap 1 or first growth phase. Synthesis of functional protein and RNA express the cell grows in volume. It covers the 30 to 40% duration of cell cycle. S phase is the period during which DNA synthesis occurs, hence called synthesis phase. In which DNA synthesis this results in doubling of the chromosomal threads. 7 hours. Duration of S phase in mammals is 7 hours. S phase 7 hours. S phase 7 hours. 35 to 45. 35 to 45. G1 phase. Growth phase. It is the last phase of interphase and occurs just before the new cell division. As G2 is called the gap 2 or second. It begins after completion of DNA S phase and ends when the new division commences. Synthesis of structured protein and protein takes place and the nuclear volume increases. It covers the 10 to 20% cell. And the significance of interface during interface, the cells metabolically very reactive and prepares itself for this division. Three important processes occurs in interface. Replication of chromosomal DNA, synthesis of RNA, and the basic nuclear proteins. Synthesis of energy-rich compounds which provide energy for mitosis, and in animal cells, the division of the centriole. Mitosis phase or M phase. This is a significant phase in a cell cycle. It begins at the end of G2 phase and continues till the introduction of G1 phase. It covers the 10 to 20% duration of cell cycle, and during this period, mitosis division of cell occurs, hence called the mitosis phase or phase. In this phase, a parent cell divides into two daughter cells. During duration of M phase in mammal is 1 to 1.5 hours. The total duration of cell cycle varies greatly in different organisms under different conditions. For example, it may take as short as 20 to 30 minutes in the bacterium, Escherichia coli, E. coli, or may take 12 to 25 hours in most higher plants and animals. Regulation of the cell cycle. How cell cycle is controlled is very complex. The following terms are some of the features that are important in regulation. Places where errors can lead to cancer. Cyclins, CDK complex, cyclins CDK MPF complex, P53 protein, P27 protein. Significance of cell cycle in a multicellular organism. The cycling type of dividing cells help in reproduction, growth, and replacement of dead cells, healing of wounds, etc. The interface allows time for synthesis and growth of the dividing cell. Properly controlled and regulated cell cycle results in normal and proportional growth of organisms. Loss of control over the cell cycle can lead to cancerous growth. Differences between E6 and E7 now. Difference between interface and mitotic phase. It is preparatory or resting phase of the cell division. It is divisional phase of the cell division. It is the longest phase and spends 90 to 95% of the cell cycle. It is a short phase and spends 5 to 10% of the duration of the cell cycle. It includes gap 1 synthesis and gap 2 phases. It includes prophase, prometaphase, PMAT. Yeah. Prophase, prometaphase, metaphase, anaphase, and telophase. Qualitative and quantitative growth of different cell materials held in this phase. Qualitative and quantitative. Dispersion and division of different cell materials held in this phase. Hereditary materials exist as chromatin in this phase. Hereditary materials exist as chromosome in this phase. Chromatin chromosome. Stages of mitosis. What I really like about the teachers in our school is that they make the studies look really easy. Like they're really skilled. They really know what they're doing because today I just learned chemistry Boyle's law. Like the law itself is not hard, but the concept of why what the constant is, what the like the teaching method is just fabulous. And the and the funny thing is, it was the goofiest teacher in our school. We used to call that teacher like the goofy one. Like the teacher's name is I won't tell the teacher's name because that will become given. But the teacher is like that sir is like too good to be true. Sir himself is enjoying teaching us chemistry. That's the like the whole class. He had a huge ass smile in his face. It was really wholesome, I would say. If you need to take a look at some videos for reference for the sales cycle, so that's exactly what I'm going to do right now. Showing you the screen. Oh shit, the way too smart. What do you mean? Okay. So I will be showing you what video I'm watching, and also let's see this. This is not good. This is also not good. Yeah, this is the best screen I have. So or what I can do is I can instead of this I can use the HD webcam. Anyways, like, leave it. Yeah, so I will be showing you what reference videos I'm watching, and this is like a feed of my YouTube. Not that impressive. Anyway, so first of all, what I'll be doing is I'll be taking a short break for peeing for washroom. So let's see you in 2 minutes. Yeah. Or I can use the OBS Studio one. This one is also not bad. This one is better, I guess. So I'll be using that one. So, cell interface explained. Explained. My computer is really heated, and I'm kind of worried actually. Oh, that's cell cycle, not cell interface. Cell cycle. Yeah, the Amoeba sisters. I really like the Amoeba sisters, but I feel like it's wait.
Have you ever been sitting in
What happened?
Class.
Okay, so what I'm going to do is I'll be using the inbuilt screen sharing method in YouTube. So yeah, here is, if you want to follow along, you can follow along.
This very moment. This kind of pondering may be unique to me, maybe. But wouldn't we at some point wonder what our cells are doing right now? Because if you remember, as part of the cell theory, you are made of cells. All living things are made of one or more cells. Many multicellular organisms like you have cells that work together, working together as part of a body tissue, body tissues working together as part of an organ, organs working together as part of an organ system. Your cells are specialized to work in these different levels of organization. You have skin cells, stomach cells, muscle cells, just to name a few, and their functions need to be regulated. These cells actually are regulated as part of something called the cell cycle. And that is going to relate to my question of, I wonder what my cells are doing right now. Cells themselves can grow in size, but let's put it in perspective now. A multicellular organism isn't growing because each individual cell is getting bigger. A multicellular organism itself grows by making more cells, by the cells making more cells by that's cell reproduction. One reason that you're bigger than you were when you were 5, unless you are 5, is because your cells have divided to make more cells. Mitosis and the cytokinesis that follows, that splits the cytoplasm, allows you to make new body cells. But you don't want that cell division happening all the time. Why? It is likely that you've heard the term cancer before. We have had family members that have battled cancer before. It is definitely a relevant topic for all of us. Cancer is in part due to cells that divide too frequently. The cells are not regulated, they are uncontrolled. Cancer cells can have other problems too. They may not be able to communicate with other healthy cells. They may not be able to carry out normal cell functions. They may not securely anchor themselves like other cells do, which can make them more likely to travel somewhere else. Some cancer cells have the ability to secrete their own growth hormone that makes blood vessels divert over to those cancer cells and supply the cancer cell with nutrients, which can take nutrients away from healthy cells. Why do cancer cells become this way? Well, there's a lot of research in this area. With some cancers, there may be genetic links, making some cells more susceptible to having problems. These genetic factors might run in families. Exposure to toxins, radiation, excessive exposure to UV light, all of these can be risk factors for some cells to become cancerous. The uncontrolled growth that cancer cells have gives rise to more cells like them, which can develop into a tumor. Some tumors stay put, but some do not. Now, the good news is that scientists continue to develop better treatments, which include destroying the cancer cells with radiation or medication, such as chemotherapy, which will target cells that divide frequently. Maybe someday you will be part of helping to meet the challenge of trying to eliminate cancer, because the fact remains that these cells are not participating in the cell cycle like they should. So, what is the cell cycle? The cell cycle is often represented as a pie chart like this. Cells are either in one of two different phases. A phase called interphase, where the cells themselves are growing, replicating their DNA, doing their cell functions, or they are in M phase, which includes mitosis and the actual splitting of the cytoplasm, cytokinesis. So, this M phase is where cells actually divide to make more cells, but cells spend most of their time in interphase. So most of the time, they're not dividing. Now, depending on phase, so most of the time, they're not dividing. Now, depending on what kind of cell, it might do mitosis more or less often. For example, your hair follicle cells do mitosis frequently, which is why your hair can grow at the rate that it does. It's also why many cancer drugs may also target hair follicle cells because many cancer drugs go after cells that do cell division frequently. It's a big deal for cells, which is why your hair can grow at the rate that it does. It's also why many cancer drugs may also target hair follicle cells because many cancer drugs go after cells that do cell division frequently. It's a big deal for cells to hit this M phase. If a cell has an error, a harmful mutation, for example, you do not want it to divide because then it will create another cell that has this same. Cells spend most of their time in interphase, kind of sepal cells. It's also why many cancer drugs may also target hair follicle cells because many cancer drugs go after cells that do cell division frequently. It's a big deal for cells to hit this M phase. If a cell has an error, a harmful mutation, for example, you do not want it to divide because then it will create another cell that has this same issue. That's where checkpoints come in handy. Along the cell cycle, there are checkpoints to check that the cell is growing well and replicating its DNA correctly and doing everything it's supposed to do correctly before it divides. To better understand those checkpoints, let's further divide this cell cycle pie chart. We have G1, S, G2. All three of those are part of interphase. Then we have M phase, where mitosis will happen. During G1, the cell individually itself grows. Then it replicates its DNA in S phase. You can remember that because the S is for synthesis, which means to make something, and it's making DNA. Then G2, the cell grows some more in preparation for mitosis. So let's take a look at checkpoints. We've got one here in G1. This checkpoint checks, is the cell growing well enough? Is its DNA damaged? Because if it is, you definitely don't want it to move on to S phase where it would replicate DNA. Does the cell have the resources it needs if it were to keep moving on? This checkpoint in G2 checks if the DNA was replicated correctly. Is its DNA damaged? Because if it is, so let's take a look at checkpoints. We've got one here in G1. This checkpoint checks, is the cell growing well enough? Is its DNA damaged? Because if it is, you definitely don't want it to move on to S phase where it would replicate DNA. Does the cell have the resources it needs if it were to keep moving on? This checkpoint in G2 checks if the DNA was replicated correctly back in S phase. Is it growing well enough? Does it have the resources it needs to continue? Okay, then moving on. This next checkpoint in M phase is my favorite checkpoint. It checks in the stage metaphase to make sure the chromosomes, which are made of DNA, are lined up in the middle correctly, that they're all attached to the spindle correctly, because if they're not, the chromosomes will not be separated correctly. So now you may have two big questions. First, what happens if the cell doesn't meet the requirements of the checkpoint? And second, what is doing the regulating of this cycle anyway? To address the first question, if the reason the cell can't go past the checkpoint is a reason that can be fixed, the cell may kind of pause here until it can fix that issue. But if it can't be fixed, then the cell does something called apoptosis, which
Yeah,
basically
yeah,
means
I
the
know
cell.
I know apoptosis, guys. Like we studied it here. Like that's the thing why I like the Moiba sisters, because they're like a teacher themselves.
Self-destructs. This ensures that a cell that is damaged beyond repair will not go on to divide. So, what is doing the regulating anyway? We've mentioned before that proteins are a big deal. Genes in your body can code for proteins that do an assortment of functions, and there are many proteins involved. But if it can't be fixed, then the cell does something called apoptosis, which basically means the cell self-destructs. This ensures that a cell that is damaged beyond repair will not go on to divide. So, what is doing the regulator a big deal? Genes in your body can code for proteins that do in the cell cycle. Some of them are positive regulators because they allow moving forward in the cycle, and some are negative regulators that might make things stop. The proteins themselves can be sensitive to cues inside and outside of a cell. So, for example, two proteins that are involved in positive regulation are cyclin and CDK. CDK is specifically an enzyme protein, a benzyme.
Cyclin dependent kinase. Cyclin dependent kinase. Cyclin dependent enzyme with cyclins. move from G1 to S or G2 to M. CDK, cyclin dependent kinase. CDK is cyclin dependent kinase. So this
called a kinase, which is worth a Google. CDK can have different forms of cyclin protein bound to it. Different types of cyclin rise and fall throughout the cell cycle, and the rising and falling is based on a variety of signals to determine when the cell should move on to the next cell cycle phase. Typically, each cell cycle phase, G1, S, G2, M, will tend to have a different cyclin binding with the CDK. The rise and fall of cyclin types and the role CDK has when it's active is a fascinating subject to explore. Remember that vocabulary word we said, apoptosis? Proteins that are negative regulators, for example, a protein called P53, can be involved in initiating apoptosis. Again, we encourage you to explore beyond the video. One last thing to mention. There are some cells that don't go through the phases we mentioned because they're actually in G0. That's a zero, by the way, and not a no, because if it was a no, then it's a go, and G0 is kind of the opposite of that. G0 is a resting phase. Now, cells here are still performing cell functions, but they're not preparing to divide. Some cells go here temporarily. They'll go through the of initiating apoptosis. Again, we encourage you to explore beyond the video. One last thing to mention. There are some cells that don't go through the phases we mentioned because they're actually in G0. That's a zero, by the way, and not a phase we mentioned because they're actually in G0. That's a zero, by the way, and not a no, because if it was a no, then it's a go, and G0 is kind of the opposite of that. G0 is a resting phase. Now, cells here are still performing cell functions, but they're not preparing to divide. Some cells go here temporarily, maybe if there's not enough resources around, for example. But some, like many types of neurons in your brain and spinal cord, may stay here permanently. If they stay here permanently, they'll never get to M phase, so they will not divide. This can be one reason why a major injury to the brain or spinal cord can have challenges with healing, as many of those cells may not be able to replicate, a topic that definitely continues to be researched. Well,
Professor Dave here. Let's talk about the cell cycle.
He knows a lot about the science stuff. Professor Dave explains.
In biochemistry, we learned about how small molecules, like hormones, can act as messengers, interacting with receptors in the plasma membrane or within the cell. Interacting with molecules, like hormones. In biochemistry, we learned about how small molecules, like hormones, can act as messengers, interacting with receptors in the plasma membrane or within the cell that then amplify the signal or activate and carry out some cellular function. But we didn't learn much about what these functions are exactly. As it happens, many of these signals regulate the cell cycle. This is the series of stages that a cell goes through in order to copy all of its genetic material and eventually divide into two daughter cells, which is how prokaryotic life initially proliferated billions of years ago. This is also how new cells in our bodies form to replace the old ones. When cell division occurs, each new cell has a copy of all the genetic material, and these daughter cells are completely identical. So how does this work? How do we get two cells from one? The first thing we have to do is understand how all the DNA is arranged in the cell. Each daughter cell needs a complete copy of all the genetic information, or genome. And while prokaryotes often have just one circular DNA molecule, eukaryotic cells have many different linear DNA molecules called chromosomes. All of this material has to undergo replication. And then the two sets must be separated before the cell divides, leaving each daughter cell with a copy. different eukaryotic species have different numbers of chromosomes, and us humans have 46 chromosomes in all our cells, which are basically all your cells, excluding the ones. That's a set of 23 chromosomes from each parent. Each chromosome consists of a DNA molecule wrapped around proteins called histones to form nucleosomes. This chromatin fiber undergoes supercoiling for storage when not in use, but will uncoil to undergo replication. To understand exactly how DNA replication works on the molecular all your cells, excluding the reproductive ones. That's a set of 23 chromosomes from each parent. Each chromosome consists of a DNA molecule wrapped around proteins called histones to form nucleosomes. This chromatin fiber undergoes supercoiling for storage when not in use, but will uncoil to undergo replication. To understand exactly how DNA replication works on the molecular level, check out my tutorial on the subject now. Otherwise, we can take for granted that at a certain point, all the DNA in a chromosome is copied, resulting in two identical sister chromatids. These are attached at the center by a centromere, with the chromosomal arms extending on either side. Later, when the cell divides, the sister chromatids will separate and get pulled into each of the two daughter cells. So when does the genome replicate? When does it get pulled apart? And when do we get two completely new cells? Let's examine the different stages of the cell cycle now. Although cells do divide, most of the time they are not dividing. They're just being cells. The time that a cell spends dividing is called the M phase, or mitotic phase, and the time spent not dividing is called the interphase, or the phase in between divisions. The interphase is comprised of three subphases. Those are the G1 phase, or first gap, the S phase, or synthesis, when the genome gets copied, and the G2 phase, or second gap. These gap phases were named as such because it first appeared that not much was happening during these times. Later, we came to understand that there is an incredible amount of cellular activity that must occur in order to prepare for the S phase and the M phase. This is because the new cells don't just need their own genome, they also need all of the other cellular components and organelles. So these must be produced as well. The G1 phase, which marks the beginning of a cell's life, involves cell growth. Some cells divide very infrequently or not at all. So cells can spend a long time in this phase, or a related phase called G0. Other cells that divide more rapidly may spend only a few hours in this phase. In adult humans, the S phase takes 10 to 12 hours, and as we said, results in two identical copies of the genome. The G2 phase takes about 4 to 6 hours and involves more growth and preparation for cell division. And then the M phase, or mitosis, has the cell dividing into two daughter cells, which takes about an hour. Other animals have significantly different rates for these phases, as do human embryonic cells. What controls the cell cycle? How does a cell know when to enter the next phase? This is crucial to understand because some cells inside the human body, like skin cells, are dividing very frequently, while liver cells don't divide much at all, and fully formed nerve cells never do. These discrepancies can be accounted for when we examine the ways that the cell cycle is regulated on the molecular level. This is called the cell cycle control system, and it is regulated by small signaling molecules in the cytoplasm. These trigger and coordinate key events throughout the cycle. There are moments during or in between phases that are called checkpoints, where the cell must receive a specific signal to move forward. One of these occurs during the S phase to ensure that DNA replication occurs without any problems, and others happen during the G1 phase, at the end of the G2 phase, and during the M phase. So what could these signaling molecules be? Most of them are proteins that fall into two categories: protein kinases and cyclins. The protein kinases are enzymes that activate or deactivate other proteins by phosphorylation, the act of adding a phosphate group to another molecule. We talked about these briefly when we examined receptors and signal transduction. So this is one way that a message can be transmitted around a cell. These kinases are always in the cell, floating around, but they are usually inactive. Once attached to a cyclin, they become activated. Cyclins, unlike the kinases, have greatly varying concentrations in the cell, and a kinase that must be bound to a cyclin to activate is called a cyclin-dependent kinase. B-type or mitotic cyclins are synthesized through S and G2 phases, and once they coordinate with kinases, these MPF complexes, or maturation promoting factors, allow the cycle to pass the G2 checkpoint, and they then perform a number of tasks throughout, or maturation promoting factors, allow the cycle to pass the G2 checkpoint, and they then perform a number of tasks throughout mitosis. Later in mitosis, cyclin gets degraded, and the kinases go back to being inactive until the next time around the cycle. There is also a checkpoint during the G1 phase that is called the restriction point. This is a stop point that must be overridden by a signal in order to continue to the rest of the cycle. In absence of this signal, the cell remains in the G1 phase or moves into the G0 phase, which is a non-dividing state. Most of our cells are in the G0 phase at any given time, but these can be called back into the cell cycle by external signals like growth factors, which can be released during injury to stimulate cell growth to heal the wound. So we can think of the G1 checkpoint as the primary point where the cell determines whether it will divide or not. The third checkpoint is in the M phase, and it governs the separation of sister chromatids during mitosis, which we will learn about later. So we now understand the phases of the cell cycle and a little bit about how this is regulated. Regulation is incredibly important because certain cells in your body need to divide rapidly, and others shouldn't divide at all. If cells are dividing, they also need to know when to stop, like the way cells in a culture will stop dividing once they have filled up their container. This is called density-dependent inhibition. If the cells were to divide further, there would be no room, and they would all suffer. Alternately, if some are removed, they continue dividing again to fill up the vacancy. This occurs due to surface proteins on each cell. If they bind to receptors on adjacent cells, this sends a signal that inhibits cell division, even in the presence of growth factors, so only the ones with empty space nearby continue to divide. So what happens when regulation of the cell cycle goes wrong? In a word, cancer. Cancer involves cells that are dividing out of control, which leads to the development of a tumor. Cancer cells are like regular cells, except that they do not follow the instructions carried by the signals that normally regulate the cell cycle. They may continue to divide even when no growth factor is present, or when there is no room for more cells. This can happen for many different reasons, which is why there are so many kinds of and abnormality or not gene expression. And if this result is crucial for regulating the cell cycle, transformation, or behaving like proteins on the surface. This can be recognized by the immune system and destroyed. But if not, it can divide rapidly and produce a tumor. This is why cell division, even in the presence of, think of the G1 checkpoint as the primary point where the cell determines whether it will divide or not. The third checkpoint is in the M phase, and it governs the separation of sister chromatids during mitosis. Kinases go back to being inactive until the next time around the cycle. There is also a checkpoint during the G1 phase that is called the restriction point. This is a stop point that must be overridden by
What I will do now is that I will make a small note because I have ingested a lot of information, but the thing is, I need to note it down or I will not regain the information that I've ingested. So that's what I'm going to do. I'll make a small chart and notes. Also, one thing about biology is that you need to learn how to draw diagrams because most of the marks in biology depend on like the drawings and stuff. Seems like someone new joined us. Someone like keeps joining and going, but most of the time I am empty. I'm alone in this room. G1. G0. Oh, it seems like it's my friend Mahi. Finally, he came. So yeah, bro, it's your T-shirt. The one you gave, I really like it, man. Like it fits really well. Thanks once again. I'm studying biology now. Like you can study stats if you want to study with me, or you can go with your own flow. No problem. You can miss your alarm. You can join whenever you want to because not everyone has to complete the syllabus like in 4 months. Who does that? Like that's literally like an autistic thing to do. Uh, that's literally a devilish thing to do. You should not take that much stress. Tell me one thing. You want to join the live stream? Like we both have the videos. Like you want to show off background sound. I don't think there is a background sound, but I don't know why you're hearing the background sound because I don't have a background sound, bro. I only have AC working. Like, how is the background sound? Is it like zzzz or what? I don't know because I cannot look at the stream. Wait, let me call you. Let me call you. Come in Discord, okay? হ্যালো।
হ্যালো।
হ্যাঁ, কি আমার স্ট্রিমে কি অনেক বেশি সাউন্ড? ব্যাকগ্রাউন্ডে তো আমি কোনো নয়েজ দেই নাই। লাইক আমার উম, এমনি তো কানে কি নয়েজ আছে? শুনোস না?
ভাই তোর যে কি ল্যাগ দিচ্ছে শুনছি এবার? শোন আমি বলি তুই যখন পড়বি তুই তোর মানে পুরো নিচে সাউন্ড অফ করেন কি শুনছে না?
ক।
আমার স্ক্রিনে কি অনেক না না তোর স্ক্রিনে কোনো সাউন্ড নেই। আমি বলি তুই যখন পড়বি তুই তোর মেইন সাউন্ড অফ করবি, তোর ব্যাকগ্রাউন্ডে কোনো সাউন্ড নেই। হ্যাঁ তোর অনেক চুপচাপ আছে।
Bro, we cannot talk in we cannot talk in Discord while I am joining the stream because there is a latency in taking place. Like what the thing I say now, it will reflect after like 5 seconds or 10 seconds because the live stream is not that live. Hey, someone just took control of over my laptop through any desk. Who is it? It was so damn funny. Like all of us. No, what they can say. Okay, so my friend is suggesting that I do not share the YouTube sound with you guys. So that's exactly what I'm gonna do now. I will turn off, like, yeah, I will turn off the like the window and stuff, the YouTube stuff, so that you can only hear like the rain noise or so. Mute website while streaming. So my gonna check now if you are seeing the like what the sound, if you're hearing the sound of the
by a
YouTube.
signal in order to continue to the rest of the cycle. In absence of this signal, the cell remains in the G1 phase or moves into the G.
Mahi, like, are you there? Yeah.
Zero phase, which is a non-dividing state. Most of our cells are in the G0 phase at any given time, but these can be called back into the cell cycle by external signals like growth factors.
No, man, I don't know how to turn that audio off. The only way to do that is to use another external software for the streaming part, OBS Studio. But what I found out that is that if I use OBS Studio, the lag is too much, the latency is too much, the stream is really laggy. So that's why I have like no other way but to use the inbuilt YouTube Studio. I can do is like, I don't know what I can do. I can mute myself. I can mute myself when I'm watching the video. Yeah, that's a great idea. Today I will continue however it is. From tomorrow I will like stop that. Uh, so yeah, like the Isha prayer has also the Isha Azan. So I will also have to pray my Isha prayer. And what was I doing? I was making notes for uh, biology. So I will continue that. Maybe it's gonna be the late website notifications. What's sharing? Okay, it's gonna be the like after Maghrib that people come join the stream, because most of my friends like Mahi, they like to sleep at day. So that's something, I guess. So I will continue what I was doing. You can follow along with your own rhythm. You can mute me because as of today, the I won't be muting the YouTube videos that I'll be watching because I don't know how to do that. But from tomorrow, I will make one thing that I can mute myself. The I can mute the YouTube videos that I'm watching in my laptop. I will only show the screen and for now just mute me. Uh,
Which can be released during injury to stimulate cell growth to heal the wound. So we can think of the G1 checkpoint as the primary point where
what I'll do is that when I am like watching a video, I will mute myself. That's a great idea my friend gave me. So I will mute myself and then continue watching the video. And when I want to speak, I will just unmute myself to speak. Guys, I think it is better to like take some snack now because uh, it's like Maghrib, so I did not eat anything after lunch. So I will be doing just that. You can do whatever you want. You can study. Like why am I even using guys? Like it's me and my friend. My so it's more like a end to end study session. So anyway, Mahi, you can continue your study. I'm gonna eat some food now, some evening snacks. Yeah.